NFPA Standard 72, the National Fire Alarm and Signaling Code, addresses T-tapping in fire alarm circuits. Section 3.3, 136 defines T-tapping. The requirement states the T-tapping provision shall be provided for connection of tamper and supervisory initiating device circuits in list of fire alarm control units that are designed and approved for use with T-tapping. This means that if a fire alarm control unit, or FOCU, is specifically designed and listed for use with T-tapping, it must include provisions for this type of connection, particularly for tamper switches and supervisory devices. T-tapping allows you to connect devices to a circuit at a point between the beginning and end of the circuit run, creating a T-shape. However, it's crucial to understand that not all fire alarm systems are designed or approved for T-tapping. The standard emphasizes that this practice is only permissible with listed fire alarm control units that are specifically designed and approved for it. This ensures that the system's integrity and reliability are maintained. Using T-tapping in systems not designed for it can compromise the circuit's supervision capabilities and create potential false alarm or failure scenarios. The recommended locations for T-tapping provision are listed fire alarm control units, remote transmitter panels, or RTPs, and auxiliary power supplies, or APSs. Firstly, listed fire alarm control units. These are the main panels that receive signals from initiating devices and activate alarms. If a FOCU is designed for T-tapping, it will have specific terminals or connections designated for this purpose. These terminals are typically designed to maintain circuit supervision even when a device is connected via T-tap. Secondly, remote transmitter panels. RTP are used to extend the capabilities of the main fire alarm control unit, often located in different parts of a building or campus. Like FOCUs, RTP that are designed for T-tapping will have specific provisions for this type of connection. Thirdly, auxiliary power supplies. APS provide backup power to fire alarm systems in case of a power outage. Some APS may also be designed to accommodate T-tapping for supervisory or tamper devices related to the power supply itself. It's important to consult the manufacturer's documentation for each device to determine whether it's approved for T-tapping and to understand the specific wiring requirement. When implementing T-tapping, several factors must be considered to ensure the system's reliability. Firstly, wire size. The wire size used for the T-tap connection must be adequate to carry the current required by the connected device. Using too small of a wire gauge can lead to voltage drops and unreliable operation. Secondly, connection methods. Proper connection methods must be used to ensure a secure and reliable connection. Wire nuts, terminal blocks, or other approved connectors should be used to make the T-tap connection. Avoid using methods that can lead to loose connections or corrosion. Thirdly, circuit supervision. The fire alarm system must be able to supervise the entire circuit, including the T-tap connection. This means that the system must be able to detect opens, shorts, and ground faults in the circuit. If the T-tap connection compromises circuit supervision, it should not be used. Fourthly, device compatibility. The devices connected via T-tapping must be compatible with the fire alarm control unit. This means that the devices must operate within the voltage and current limits of the control unit and must provide the correct signaling characteristics. Fifthly, documentation. It's crucial to document all T-tap connections in the fire alarm systems as built drawings and documentation. This will help ensure that the system is properly maintained and that future modifications are made correctly. When troubleshooting fire alarm systems with T-taps, it's important to follow a systematic approach. Firstly, inspect the T-tap connections. Look for loose connections, corrosion, or damaged wiring. Repair or replace any damaged components. Secondly, verify circuit supervision. Use a multimeter or other testing device to verify that the circuit is properly supervised. Look for opens, shorts, or ground faults in the circuit. Thirdly, test the connected devices. Verify that the devices connected via T-tapping are operating correctly. Check their voltage and current levels and verify that they are providing the correct signaling characteristics. Fourthly, consult the manufacturer's documentation. Refer to the manufacturer's documentation for the fire alarm control units and the connected devices to troubleshoot any problems. The documentation may provide specific troubleshooting steps or diagnostic information. The key takeaway is that T-tapping in fire alarm circuits is permissible only under specific conditions. The fire alarm control unit must be listed and designed for T-tapping, and the T-tap connections must be made in accordance with the manufacturer's instructions and all applicable codes and standards. Ignoring these requirements can compromise the integrity and reliability of the fire alarm system and create potential safety hazards. NFPA 72 is a comprehensive standard that covers many aspects of fire alarm systems, including design, installation, testing, and maintenance. It's essential for anyone involved in fire alarm systems to be familiar with NFPA 72 and to follow its requirements carefully. Understanding the specific requirements for T-tapping is crucial for ensuring the safe and reliable operation of fire alarm systems. Always refer to the latest edition of NFPA 72 for the most up-to-date information and requirements. Remember to consult with qualified fire alarm professionals for any questions or concerns regarding T-tapping or other aspects of fire alarm systems. Improper T-tapping can lead to serious consequences, including false alarms, system failures, and potentially failure to detect a real fire. Therefore, adhere strictly to the guidelines outlined in NFPA 72 and the manufacturer's specifications to ensure the safety and reliability of the fire alarm system.